Following on from the previous video, we were trying to sketch this graph in polar form. And we got to a stage where we know it's symmetrical along the y-axis and we know it's symmetrical along the x-axis. So all we need to do is really to sketch one quadrant, and then we can reflect it, and then reflect it again. So really we only need to sketch it from 0 to pi over 2. We only need to sketch it from 0 to pi over 2. We only need to sketch one quadrant, and then we can reflect it. Okay, and remember that when you work with cos theta, it's always easy to work in terms of 0, pi over 2, and in terms of pi over 4. You see, pi over 4 is easy to evaluate. Pi over 4 is really so it's like you having this triangle 1 1. This must be the square root of 2. Well, cos would be 1 over root 2. Another way of thinking about this is root 2 over 2, because you can times top and bottom by root 2. Well, when working with cos theta, it's easy to work with pi over 2. So when you're sketching the graph, try and work with numbers that would make this easy to evaluate. Well, it's easy. We know it's easy to work with pi over 2. So if you look at this here, because of this 2 here, we might want to divide this thing here by 2. So pi over 8. You see, it's easy to work with pi over 8, and maybe this over 8, because well, to just select points that would make this thing easy to evaluate. So let's try and evaluate this. When theta is 0, this thing here would be 0. Cos of 0 would be 1. So when theta is 0, the radius here would be 2. And when theta is pi over 8, well, if you put pi over 8 into here, 2 times pi over 8 would be pi over 4. So cos of pi over 4 would be 1 over root 2. That's the same as root 2 over 2. And then so cos of pi, well, this block here, when it's pi over 8, when theta is pi over 8, this block here will be root 2 over 2, root 2 over 2. And now you times 2 will kill off this 2, leaving you with root 2. Well, think about it. When it's pi over 8, the radius will be this. When it's pi over 4, the radius will be 0. And when it's 3 pi over 8, the radius will be negative root 2, and so on. When it's pi over 2, the radius will be this. So keeping track of our radius, it will look something like this. So now once we've got this, we can now sketch our graph. Remember, we are sketching it in terms of, well, this is pi over 2 here. This must be pi over 4. So half the angle here would be pi over 8, and then this one here would be 3 pi over 8. So now we're doing it from these points here. So once we've got our radius, we can now sketch our graph in polar form. So remember, this line here is pi. Well, this here is pi over 2. This one here is pi over 4. This one here is pi over 8, and so on. Okay. So when it's 0, hang on. When theta is 0, the radius will be 2. So when theta is 0, so remember, theta 0 is along here, the radius will be 2, so it's going to be right here. Going back up here, when it's pi over 8, the radius will be positive root 2. So hang on. When it's pi over 8, the radius here will be somewhere around here. Okay. When it's pi over 4, when it's pi over 4, it will be 0. So when it's pi over 4, hang on. When it's pi over 4, it will be 0. So the radius. Well, remember, this here is pi over 4. when it's pi over 4, the radius will be 0. And then when it's 3 pi over 8, the radius will be negative root 2. So hang on. So this thing here is 3 pi over 8. When it's 3 pi over 8, the radius will be, well, this here is positive root 2. Or negative root 2 would be you going the other way. It would be you. So this here is positive root 2. But then negative root 2 would be in this direction somewhere around here. Okay, and then when it's pi over 2, the radius will be negative 2. The radius will be negative 2. So hang on. So when it's pi over, bear with me. When it's pi over 2, bear with me. So when it's pi over 2, which is along here, the radius will be negative 2. So that would be all the way down here. So it would be here. So from theta being from 0 to pi over 2, it's actually doing this. Hang on, it's actually doing this. Bear with me. Hang on, bear with me. It's actually doing something like this, which is hard to draw. So our graph looks something like this for one quadrant. Now reflect it. So this is what we've got so far. Don't forget it's symmetrical along the y and it's also symmetrical along the x. So as it turns out, it will look something like this. Okay, symmetrical along the y. So it will look something like this. Hang on, bear with me. And then it will look something like this. Something like that, and then it will look something like this. Badly drawn, but it's going to look something like this because all that we had right from the start, was something like this. All that we had right from the start was something like this, and then reflect it accordingly. We'll get a graph plotter and plot it. It will give you this. Okay, so this here is your final graph. So when we did it from theta being from 0 to pi over 2, it gave us this. Hang on, it gave us this. Okay, it gave us this here, and then we had to reflect it. Well, if you reflect it properly, it will then give you this thing here. Okay.